Okay, so okay, once more, guys. Good evening and welcome to our today's class. We want to talk about something very, very important, and this is what is called IP static routing. IP static routing. And to start us off, just check out the objectives of what we're going to study this evening. So we are going to configure IPv4 and IPv6 static routes, and this is very important, especially when it comes to your exams, the industrial exams. And so we're going to describe the syntax of configuring static route, basically the command structure, and then we'll configure IPv4 and IPv6 static routes, and we will look at the different types of static routes. You know, we have different types of them, and we'll talk about that. Then we're going to configure IPv6 and IPv4 default static routes, and of course, we'll get to know what does default mean. Then we will also configure what is called a floating static routes. Floating, you can also call it a backup static route. Basically, to provide backup wherever one link fails, you can always use another link. And then we will configure what is called host static routes. Host static routes. This is a route that directs traffic to a specific host device, and we'll do that for both IPv4 and IPv6. Now, I want to start by giving you a brief that after we talk about the types here, I will give us a brief topology, and that is what is called the model topology that we're going to use for this particular class today. And so I would like you to get the foundations, because if you get the foundations, you will not have any challenge even when you're doing the assignments. Now, among the static routes that we're going to be configuring, one is called a standard static route. Standard static route. Then we have the default static routes, Then we have what is called the floating static routes. And then we have the host static routes. And then we have the summary static routes. Now, the standard static routes are normally divided into three, and that is where the foundations of all the other ones will come from. And so it is high chance that we talked about those standard static routes. And so for the standard static routes, you can see we have three options. We have what is called the next hop static route. We have the directly connected static route, and we have a fully specified static route. So next hop static route, directly connected static routes, and then we have the fully specified static routes. Now, I want to take us on a journey of using this topology here, and I think this should be able to give us a very good foundation of configuring our static routes. So I want you to pay attention and get to understand whatever it is that I have to take you through right here. Now, I want you to look at this diagram, this topology, three routers as usual. So now that there are three routers, I'm tempted to ask you guys, and I want this to be as interactive as possible. I want someone to tell us how many networks are here. How many networks can you see? Someone? Yeah, because that's where we have to start, ladies and gentlemen. Let's respond so that we save on time. How many networks can you see here?
I can see 5.
All right. That's a good response over there. Can I get someone to confirm or to disagree?
Yeah, there are 5.
Just
net.
one. Correct. So we all agree there are 5, and just for the avoidance of doubt, I'm gonna count them. So we have the LAN here on R1. This is one network, and like I told you, this is the name of this network. We can have an IPv4 name, which is 172.16.3.0/24. That's the name of this network. You can also call it with an IPv6 name. 2001:dbh::ACAD:3:/64. So this is the name of this network. This is a LAN on R1, and the network addresses are actually here, version 4 and 6. We both agree this is the other network, the one joining R2 and R1, or R1 and R2. So this is the second network here, and it is for here. It is for this particular link over here. Of course, the third network is the LAN on R2, right? This is the LAN on R2. Then we have a WAN network right here, a WAN network joining R2 and R3, this one over here, all right? And then the last network is the LAN on R3, all right? So every network, every router has its own LAN. Every router has its own LAN, but every router also has a WAN connecting to another router. So R1 to R2 is connected with the WAN here. R2 and R3 is also connected with the WAN here. The only network that is not connected, and we shall see later on, is R1 and R3. They do not have a link in between them. But as we can see, we do have 5 networks here, 3 LANs and 2 WANs. Now, let's go a step higher. Guys, I'm trying to be as sequential as possible, because it will pain me if you do not get the concept. And that is my major business here. And I want you guys to get the concept. That is the bottom line. Concept, concept, concept. All right, let's go to the next step. Now, looking at this diagram, I want you to we want to talk about 2 things. The first thing we want to talk about is what is called an exit interface. And I know that I've talked about this before, but I need to emphasize it because it is key in terms of the configurations we are going to make. And if you can't identify those things, you are going to just have serious problems. And that is not what I'm wishing for you guys. So I had told you before, all right? I have told you before that, let me just pick a pointer here. I've told you before that looking at the interfaces of R1, R1 has this interface, and you see, yeah, like this. You see number 1 here. This one is always used to replace either where the 0 is here, or it can also be used after the double colon here, such that the IP address, IPv4 address of this interface is G000 is 172.16.2.1. All right. And the IPv6 address is 2001 colon DB8 colon ACAD colon 2 double colon 1. All right. So you're gonna need to know how to name your interfaces. Actually, I'm doing it wrongly. Okay. This is this network here. Their addresses are actually down here. Sorry about that. So the IP address of G000 is 172.16.3.1, and the IPv6 address is 2001 colon DB8 colon ACAD colon 3 double colon 1/64. All right, and so is the upper one here, 172.16.2.0. So the IP address of serial 0/1/0 is 172.16.2.1. All right, and the IPv6 is 2001 colon DB8 colon ACAD colon 2 double colon 1/64. All right, so I want you to look at this from R1 here. This is our router R1. And so from this router here, if this router needs to send a message, if the router R1 needs to send a message to the computer on this R2 LAN, all right? It needs to send a packet or a message to this LAN over here. Remember, that message must live through this interface. See this interface here, which is here. The message has to live through interface serial 0/1/0. And you realize, even if that packet is going to the LAN of R3, all right? If the message from R1 is going to the LAN on R3, the message must still leave the router R1 through interface serial 0/1/0. That is paramount, and that is not going to change. So the interface that message will leave from our router R1, that interface is called an exit interface. It looks simple when I say it, trust me, we are going to need that concept to configure static route. So the interface that the packet will live through from R1 to either R2 LAN or R3 LAN, or even the one between R2 and R3. That interface is called exit interface. All right, that is the exit interface. So that is how we get the exit interface. And of course, it's not just for R1. For R2, the interface that messages will leave from R2 to R1 LAN. This is R1 LAN from R2. They'll use this exit interface here, which is serial 0/1/0 of R. This will be the exit interface. Of course, R2 coming to R3 LAN will have to use serial 0/1/1. All right. So those are called exit interfaces. Those ones are called exit interfaces. And it is important to note that, of course, even R2 to its own LAN, it will still use its own exit interface here, G0/0/0. Now, listen to this. The next thing, if R1, right, R1 wants to send something either to R2 LAN or to R3 LAN, okay, R1 must not only send that message through its exit interface, all right, but the first router on its way towards sending it to the R2 LAN or to R3 LAN, the first router to meet on its way is R2, all right? And that is what we call a next hop router. Actually, it's called next hop because the word next hop means next router. So the word hop actually means router, okay? And so what I'm saying is for R two, sorry, R1, for R1 to send a message to R2 LAN or to R3 LAN, the message, yes, will go through the exit interface of R1, but the first router on its way towards either of those two LANs is R2, and we are calling it the next hop or the next router along the way. Now, talking about that next router, which is R2 from R1, which interface will R1 use to send that message? Or through which interface of R2 will that message get into R2? The interface is interface S0/1, all right? The interface of the entrance to R2 is S0/1/0, okay? But when you're talking about the next hop, you don't talk about the interface, all right? I repeat that. When you're talking about the next hop router, you don't talk about the entrance interface. You talk about the IP address of that interface. Guys, I want you to be with me. This is crucial. When you're talking about the next hop, don't talk about the interface itself. We talk about the IP address of that interface, all right? And that IP address, if from what we have talked about, the IP address of this S010, this interface here, is 172, all right, .16.2.2, all right? Since this interface is, and the S01 of R1 and 2, they are sharing this network here. This is their one. So like I said, don't talk about the interface itself of the next hop router. You talk about the IP address of that particular interface, which is version 4 is 172.16.2.2. For IPv6, it's 2001:DP8:2:2:2/64. All right. Now that Guys, can you hear me? Someone to confirm. I know there was a little bit of interruption.
Yeah.
Yes,
Yeah.
Okay.
yes.
Okay. Thank you. Thank you. All right. So let's continue. I was driving a very important point, and I still want to just pick up where I left. So, like I said, R2 is called the next hop router, or the next hop, or the next router. And we look at the IP address of the entrance interface to R2, which is our next router on the way. Now that IP address, which is for version 4 is 172.16.2.2, we call it the next hop IP address. Very important. Very, very important, guys. So the next hop IP address, which means for R1 to send a message, for R1 to send a message to the LAN of R2 or to the LAN of R3, R1 needs to know either of these three things. Number one, R1 just needs to know the exit to get to R2. That is number one thing that R1 needs to know. Or R1 needs to know the next hop IP address of the next router. So R1 needs to know the exit to reach the next hop router or the next hop, or R1 needs to know the next hop IP address, which is the IP address of the entrance to the next hop device, or R1 needs to know both of them. Did you get that? So you either know the exit door. It's like, you want to go to someone else's room, okay, or house, or you want to go to the estate. So you either know the exit of your door, or you know the door number of that person you're going to see, or better still, you know both of them. You know which door to exit from your house, and you know which door number to enter the other side. So, and that is how these static routes work. And ladies and gentlemen, if I can still take you back, because I want you to be with me. I want you to know what exactly are we doing here. So what we are doing is this. I want you to get static routes, because I know some of you might have not been in class yesterday, not yesterday, on Friday. Now, what we are doing here is routing. And in routing, what is the objective of each router is to learn about the remote networks. And what did we say? We said that R1 is directly connected. R1 is directly connected to two networks. This network here and its LAN here. These ones are two directly connected. This one here and this one here. Those ones are directly attached to R1. R2 is directly attached to this network, the LAN here, and the one here. So R2 has three directly connected networks. R3 has two, which is this one and the LAN of R3. Okay. Now, the directly connected network is not always a problem, because those ones, by just configuring the interfaces of the router and activate those interfaces, configure the IP address and activate, the router registers them in the routing table. Now, the bone of contention is how can each router learn the remote network? So we ask ourselves, what is a remote network? In this diagram, a remote network is a network that you must go through another router to reach it. That is the simple definition of a remote network. For example, here, the router R1, let me just remove these writings here. Correct. So the router R1, even though it is directly connected to two networks, it is not directly connected to three more, which means it is not directly connected to LAN of R2. It is not directly attached to this one network, and it is not directly attached to the LAN of R3. And so objective of R1 is how can I learn the remote networks and add them in my routing table? That is the objective here. And so what's going to happen is this. We said last week that there are two methods of configuring of R1 learning the remote networks. Number one, which is what we are doing today, is we are going to manually add the remote networks to R1 using a method we call static routing. That is what you're going to do. We are going to manually add those the remote networks of R1 to R1, all the remote networks of R2. You see, R2 has 3 directly connected networks, but 2 remote networks. These ones are the remote networks of R2 because R2 must go through either R1 or R3 to reach those LANs. R3 also has 3 remote networks, the LAN of R2, the one between R2 and R1, and the LAN of R1. So the objective is always one, learning the remote networks. How do you do it? Number one, using static routing, you use the network administrator, you're going to manually add the remote networks of each router to that router, okay? And as you add them, we are going to use those 3 methods I talked about. You're either going to identify the exit interface, or you identify the next hop IP address, or you identify the both of them actually. I realize I only told you one side. I didn't tell you. So I told you from R1, what is the next hop when R1 wants to send a message to the LAN here, and the LAN here, and the one here. R1 needs to store the 3 remote networks. And that means we can add those 3 remote networks to R1, either by setting the exit interface or the next hop IP, or please don't state the next hop interface. There's nothing like next hop interface. It is next hop IP, but it is exit interface. Exit also, you cannot state the IP address. Let's go to R3. R3 wants to send a message either to LAN of R2, to one between R1 and R2, or to the LAN of R1. Just like R1, R3 also has one exit interface, which is S0/1/1, or the next hop IP, which is 192.168.1.2. Okay. And so R1 can use the exit interface, the next hop IP, or use both of them. And those one stands whether R3 is going to the LAN or the one here or this LAN. The next hop and the exit, they remain the same. Okay. The only time there will be a difference, and we shall see that, is when there was a link between R3 and R1, such that R3 can either go through this link this way, or R3 can go through this way. And we do that when we be configuring what is called a floating static route. Now, at this point in time, I've already talked about manually adding those remote networks to each router. The only other way is what is called dynamic routing protocols, whereby those routes will be learned automatically by just enabling the protocol in R1, in R2, and R3. The routers are going to exchange. In fact, each router is going to advertise its directly connected networks to all the other routers. And it will happen among themselves until every router has learned about the remote networks of its own. And that is very important. I want to give a few seconds, for you guys to ask me any question, because this is crucial. If you have not understood anything, if you want any clarification, because we want to go to how do we configure them. That is the big deal. Anyone wants to confirm anything? I'm giving you this opportunity. All right.
Excuse me, I have a question
Okay.
about the next hope.
All right.
What about if it's R3, the initiator of the message? How will it happen? Because
sorry, just if R3 is initiating, going to where?
Going to maybe R1.
R3 going to R1. Very good. The next hop will be the same. Then so let me ask you, what is the next router along the way to R1 from R3?
It's at R2.
R2, which is the IP address that R3 uses to enter R2. You can hear me?
Yeah, I can hear you.
Yes, yes. R3 will enter R2 through which interface of R2?
Is it S011?
Very good. What is the IP address of that interface?
192.168.1.2/24.
Very good. Yes, that one does not change. Next hop is the next router's IP address. How do you enter the next hop? So you always look at the next router along the way, then look at the IP address of its interface. Whether you are going to R1, whether you are going to where, even if there was another link coming this way, the next route, the next hop remains the same.
Oh, thank you. Now I've
Clear?
understood. Yeah. Now I get
right,
it.
all right.
Thank you.
Thank you. You're welcome. Any other question, guys? Please. This is the best time to ask that question. Okay. I'm assuming we are good. So I want us to go to the configurations and basically see how that is going to be. All right. So let's see how this one goes here now. All right. So all right. So right here. So under standard routes, there are 3 types of standard routes. The first standard route is called a next hop static route. In a next hop static route, you use the next hop IP address. That is very crucial. You use the next hop IP address, you state it. Then the next one is called a directly connected static route. This is the one where you use the exit interface directly, because it is directly connected. Static route, you use the exit interface. Then the last one is called, and by the way, the exit, then the directly connected static route, the next hop. Yeah. So the next hop has another name. You will hear it in the exams. It is not indicated here, but you'll hear people calling it recursive static route. Okay. The next hop is also called a recursive static route or next hop static route. And I'm going to explain to you why is it called so. Then, so that is next hop, which we use the exit in the next hop IP. Directly connected static route, we use the exit interface. Then we have the fully specified static route. You actually indicate both the exit interface and the next hop. But you start with the exit interface, then you state the next hop. I know they still look very Greek to you guys, but I'm coming very slowly so that you can get. Now, all commands for configuring static routes, they begin with IP route. If it is IPv6, we say IPv6 route. So IP route, you put the network address, put the subnet mask, then you can either put the IP address, the next hop IP, or you can put the exit interface, or you put both of them. Or on cases, you are going to need to put what is called an administrative distance, which I did talk to you guys about before, but we will reach there. Let's move slowly by slowly. This is the topology we are going to be using for our configurations. And now I wanted us to start off this and basically see how this normally happens, right? And I'm going to start with what is called the next hop static routes. And looking at this diagram, this is our diagram here. And let me just make this to be a bit clearer. So we are in R1. If you look at R1, you realize that R1 has 3 remote networks. So the first one, remote network for R1, is this network, which is 192.168.1.0. The second remote one, remember, remote means not directly connected to R1. We said there were 5 networks here, and 2 are already directly attached to R1. The ones that are not directly attached are the ones we call remote networks. So 172.16.1.0, correct. 192.168.1.0, correct. 192.168.2.0. Those are the remote network for R1. And so let's see how is it that we add those remote networks to R1. All right. So if you can be able to see that here, we are actually adding those 3 remote networks to R1. The first one, 172.16.1.0, we have 191.168.1.0 and 191.168.2.0. Because we are talking about the next hop static route, and the next hop use the next hop IP. And like I said, from R1 to either of those 3 remote networks, R1 will must use the next hop, which is 172.16.2.2. And so let me just zoom in so that you can see the 3 static routes that R1 has added here. So you can see this IP route in R1, 172.16.1.0, that is the first remote network up there. The subnet mask is /24, which is right here. And the next hop is 172.16.2.2, and that is the one we were able to identify. Okay, look at the next network, which is the network connecting R2 and R3. We say IP route 192.168.1.0, put the subnet mask, and then put the same next hop, because this is the next router's IP address. Then the third network, which is connected to R3, is 192.168.2.0, 255.255.255.0, and put the same next hop IP. Okay, so basically that is what we are doing. We are adding the 3 remote networks, but the only way to reach them is the IP address of this of the next hop IP of R2, and we are able to see that very well. Now, if you say show IP route here, show IP route, you realize that we were able to, basically learn the 3 networks. How do we see them in the routing table? You see them with an S, which means static, and these are our 3 networks here. This is the network itself. This is the subnet mask is here. The AD, the administrative distance, is 1, and the metric is 0. And when you see the word via, it means the next hop is what is there. Look at the second network is here, 192.168.1.0, which is using this. It's actually learned through static routing. That means we have configured it manually. AD is 1. All static routes have an AD of 1, by the way. Metric is 0, and the next hop is here after the word via, and so is the third one here. Next, the remote network is here, the AD of 1, and the metric is 0, and the next hop is still that one over there, and that is interesting. Now, what if we want to do the same thing, but for IPv6? The same thing for IPv6. You realize that in IPv6 here, the remote network is, the next hop from R1 is 2001:DB8:ACAD:2:2. All right, that is the next hop. The 3 remote networks is 2001:DB8:ACAD:1:/64. You must differentiate an IPv6 address from a network address. So a network address of IPv6, it does not have any number after the double colon, but an IPv6 address will have a number after the double colon just before the /64. So this is the first network. The second network is 2001:DB8:Cafe:1:0. This is my own ways of calling them, just to make it simpler, because people tend to shy away from IPv6. Instead of saying CAFE, that is very heavy on the tongue. I just say DB8. I said cafe. I said ACAD, for example, and that I feel it. Most of my students will always find it easier to call it like that. So, and the last remote network, of course, is here, 2001:DB8 colon cafe colon 2 double colon slash 64. All right. And so this is for IPv6. You can see we have also done configurations here. And of course, for IPv6, you must first start by enabling IPv6 routing by saying IPv6 unicast -routing. Then you configure the static routes. You say IPv6 route, put the network address here, and the network address must have a /64, okay, without any number in between here. And then you put the next hop IPv6 address. You can see without any 64 here. And you do the same network for cafe colon 1 double colon /64, cafe colon 2 double colon /64, and you put the next hop IPv6 address. Same thing, nothing is changing. To view the IPv6 route, you say show IPv6 route. Show IPv6 route. Of course, you're gonna see it here using the S. The S means static. And by the way, every time you say show IP route or IPv6 route, the router is very generous to give you what each and every letter here means. For example, S should be somewhere here. S means static. When you see L means local, and the local is actually local interface IP address, and you can see some L here. When you see C is connected, which means the directly connected network, actually it is the network address of that particular IP you had configured with that interface. You will later on we'll see things like O for OSPF, okay? There's there's R for RIP, there's B for BGP here. This let me see, the other D here is for EIGRP, all right? IS is for IS summary, and a couple of them here, basically. Yeah, some of them you meet in the third module, some of them you meet in CCNP. All right. So at this particular time, we also want to learn what if you decide to do the same thing, but you now configure what is called a directly connected static route, because the first ones were called a next hop static route. So for directly connected static routes, what you do is that you do the same thing, only that instead of using the next hop IP, you now use the exit interface. And you can see from R1, the only exit to any part of this network from R1 is S010. And that's exactly what we have here. So for 172.16.1.0, 192.168.1.0, and 192.168.2.0, all of them with the same subnet mask of /24. I hope you still remember how to change /24 to subnet mask. We do have the exit interface here. I can zoom in this so that you can be able to see IP route 192.168.1.0, put the subnet mask, and now put the exit interface instead of putting the next hop. All right. Instead of putting the next hop, you put the exit interface. And you can see for both of them, the exit interface remains the same. We could do that. Of course, when you say show IP route, you'll be able to see still with an S here. This time around, they'll tell you the next hop instead of, the exit interface instead of the next hop. You could do that the same thing for IPv6. And you can see that here. Instead of using the next hop IPv6 address, use the exit interface is what you actually use. And show IPv6 route, of course, will still be able to display the IPv6 static routes, IPv6 static routes there with the exit interfaces, of course. Now, I now want to look at the third one that we call the fully specified. And don't forget the recursive, which means the next hop static route. For fully specified, you now specify both of them, both the exit interface and the next hop IPs. And we are going to look at, if you look at R1 here, the exit interface is G001 to reach the other remote networks. And the next hop is actually 172.16.2.2. And so we can actually see that here. Look at it. Look at that here. You still say IP route, put the network address here, put the next hop, sorry, the subnet mask, start with the exit interface, G001, and then go to the next hop. Don't do it the other way around. You start with the exit interface, then you put the next hop IP addresses. For IPv6, of course, you can check that And when you check that by saying show IP route, the routing table will actually show you the network, how it was learned statically, the remote network itself, subnet mask, the AD is 1 for all static routes, 0 is the metric, the next hop after the word via is here, and then the exit interface will be here. And you see that for all the static routes that we actually have right here. Now, IPv6 can also begin a fully specified, but because IPv6 uses an address we call the link local address, okay? It is always, you can always still use the link local. You can always still, sorry?
A question, please. Thank you.
Yes.
Kindly go
All
back
right,
on the
please ask.
fully specified.
All right.
On the IP route, on the, I'm looking at the network address, the IP route 172.16.1, and then we have gigabit Ethernet 0/1.
Yes.
That is the exit interface, isn't it?
Of R1, yes, it's here.
Oh no, it's not a 0/. I thought it. Oh,
Yeah,
right.
no, they have changed it. They have changed it. Yeah, it's okay.
I was a bit confused. Why is it 0/0/? And then it's G. Oh, I get it now.
Yeah. They have modified the topology a bit, and that's it. Anyway, thank you for that. Thank you for that. Yeah, for being keen. Yeah. Okay. So for IPv6, for fully specified, IPv6 has an address called link local, and it uses that link local to do a good job. And when you have to use the link local, normally I think it's not used. It cannot be used alone. The link local can never be used alone as a next hop, and so you must always include the exit interface. You must always, and you can see there's an error that was thrown here. Interface has to be specified for a link local next hop. Very important. So an interface needed to be specified for the link local to be used as a next hop. But if you're using the if you're using the address itself, the global unicast address for IPv6, then you might not be required to use the exit interface when you're using only the exit interface. But you must use both of them, the fully specified. Either you state the address, or you specify the link local here. And when you use the link local, be sure you can only use it with an exit interface. That is for IPv6. Now, I wanted us to see if this is something that we can do together here, because we have seen how it is actually done. So this is a topology, and on this topology, we are now going to work on R2. We are now going to work on R2. And I want you to note these details, even though they are provided to us, but I would like you to know what we are doing. And so being at R2, you know that R2 has only 2 remote networks. R2 has this remote network, 172.16.3.0, and R2 has 192.168.2.0. Those are the only, all the other 3 are directly connected to R2. And so from R2's perspective, to reach PC1 LAN here, the next hop, the exit interface must be G001. And the next hop must be 172.16.2.1. That is going to be the next hop from R2 to this other side of the network. From R2 to R3 LAN, the exit interface of R2 will be S011, and the next hop will be 192.168.1.1. 192.168.1.1. They are going to give us the IP addresses and the next hop on the instructions, but I need you to know what we are doing. That's why we are identifying them in prior, so that even if we are given, you can do it backwards, and you can actually know where did they get that particular next hop. For example, we are going to configure R2 to reach network 192.168.2.0. See this LAN here. And you're going to use the next hop. And so the next hop is going to be 192.168.1.1. So if you're given that address, please do not ask where it is coming from, because I have shown you basically how to get it. So I'm going to zoom my screen a little bit so that you guys can have a good view of what it is that I am going to be doing. Okay. So we are told configure an IPv4 next hop static route on R2 to network 192.168.2.0/24 using the next hop address of that one. So like I said, this is very simple. The command is IP route. So I do here IP route. Okay. I put that network 192.168.2.0. Put the subnet mask of /24. You need to already have that at your fingertip. 255.255.255.0 space. Then you're putting the next hop, which has been provided, but like I told you, I'm sure you know where it's come from. 192.168.1.1. And we are good to go. You just press enter. Okay. And then it tells us we now want to configure fully specified. Just trying to help us to do what we planned up there. So for our fully specified, like I said, static route on R2 to the .3.0 network, the 3.0 network. So from R2 to the 3.0, this network here, we're going to do a fully specified, means we G001 exit interface, and the next hop is 172.16.2.1, 172.16.2.1. So let's get into it. So configure fully specified static route on R2 to network 172.16.3.0. So you say IP route 172.16.3.0 255, the subnet mask, which is 0. And then you put the exit interface is G. We are given G0, 0/0/1. Put a space and then put the next hop, which is 172.16.2.1, just like that. And you're good to go. Right? Then we are told to configure an IPv6 next hop static route on R2 to network 2 cafe:2.0 network. So let's see what that is. It's right here from R2 to this network here, from R2 to this network, and it is fully specified. No, it is actually next hop. Yeah, next hop IPv6 static route, which means we are going to use the next hop here from R2 to this LAN here is 2001:db8:cafe:1:1. That is our next hop to reach this network. So to add this remote network, we're gonna need to say IPv6 route. Okay, so let me just put this while here. So we say here IPv6 route IPv6 route, and say 2001:cafe:1. No, it's not :1. Yes, yeah. So let me just start it again. IPv6 route 2001:cafe:2:/64. Okay. Since it was next hop, the next hop is there, as we had seen, 2001:cafe:1:1. All right. And we are good to go on that. We do a fully specified IPv6 static route going to a card:364. So that is actually here from R2. We are coming to a card:3 here, and it is fully specified, which means we need G001 And we read the next hop here, which is 2001 colon DBH colon ACAD colon 2 double colon 1 double colon 1. So let's see how that goes. So we say IPv6 route, okay, and you say 2001 colon DB8 colon ACAD colon 3 double colon slash 64. That is the network, the remote network. We add it using both the exit interface and we are given a link local there. G0 slash 0 slash 1. Then you put the next hop of FE. Please do not put this one here, this slash here. That is just used to differentiate the two of them. So do not put there. So FE80, that's a link local address, double colon 1. And we are good to go. We're told to exit configuration mode and issue the command to display only IPv6. That word only is very important. So if you're told to display only IPv4 static routes in the routing table, I'm going to show you how to do. So let's exit first to go to the privilege exec mode. So to display only IPv4 static routes, you say show IP route static. Okay. So remember, the show IP route can work on it by itself. It will display all routes directly connected and static and dynamic. But if you say show IP route static, you'll only see the IPv4 static routes. If you want to see IPv6 static routes only, you say show IPv6 route static. If you want to see OSPF routes only, you say show IPv6 or show IP route OSPF. So we get there. So to display only IPv4 static routes, you say show IP route static. And you can actually see them here. The menu will always come there, as you can see right here. But your routes are always right here. You look there, you see them with an S here, for example. The only static routes we have are these ones here and this one here. 2 routes. All right. Display only IPv6 static routes in the routing table. So you say show IPv6 route static. Show IPv6 route static. And you can actually see that the routes are actually right here. All right. We are told that configure, you are now logged into R3. All right. We are now logged into R3 and we can actually go to R3. So we are told configure directly connected IPv4 static route on R3 to network 172.16.3.0 network using the exit interface. So from R3, where is this network 3.0? So this is our R3 right here. And the network we are visiting is the LAN on R1. Okay. Remember, the exit interface must be S011 since it is directly connected. And you can see that interface is here. So, sorry. So we say IP route, put the network 172. In the exam, you'll not be given this network. So you must know how to identify your remote networks. That is number one thing. They'll never give you at the static route on R3 to this network. No. You just need to know the remote networks of that R3. Sometimes they give you, sometimes they not, but you need to know where to get them. 172.16.3.0 slash 24 is 255.255.255.0. And you put the exit interface, which is S. I don't know whether they'll need capital S or small s. You see, they are refusing. They want us to use, they have given us a capital S, but they actually need you to use a small s. It is because this is syntax checker. Syntax checker is meant to put you to be on the alert. By the way, that is the major objective of syntax checker. They want you to be very, very keen. If anything you're not keen, they tell you must enter the exact and full command. So they want you to be very keen. And sometimes they make deliberate mistakes of just putting a capital S here. They want you to note that that is actually a capital S, but they want you to use a small s, which is no problem. So we're just going to repeat that. And you say IP route 172.16.3.0 255.255.255.0, and you put a small s this time round, S0/1/1, and you can see it's accepted. Okay, yeah. So it's not a mistake. It is to just let you to be keen enough. Configure directly connected IPv4 static route on R3 to reach network 172.16.1.0. 172.16.1.0. Where is that network? Is the LAN on R2? You can see it's the LAN on R2. So from R3 to that LAN, remember the exit interface is still serial 0/1/1, and the next hop is 192.168.1.2. So let's see that. Let's see how that goes. So configure directly connected network on that. So we say IP route 172.16.1.0, 255.255.255.0. And since it is directly connected, we see small s 0/1/1, and you're good to go. They want us to configure another directly connected network to 172.16.2.0 using the exit interface. 172.16.2.0. You can see it's the one between R2 and R1, 172.2.0. So let's do that. Can you hear me, guys? Hello?
Yeah. Oh,
Hello?
Yes, we
lost.
can. Yes.
Okay. Okay. Thank you. Yeah. Let me just. I think I had just some small blackout here, but that is it. So let me just let's get going here. So I was here and we were just configuring, this one here. So configure directly connected IPv4 static route there. So we'll say IP route, okay,
Excuse me.
172. Yes.
We can't see the screen.
Oh, okay. What about now? Can you see it?
Yep.
Okay, thank you. Yeah, so 172.16.2.0 as 255.255.255.0, and the exit interface small s S0/1/1, and that's it. The network configure directly connected IPv6 static route on R3 to that network. The same thing, we just say IPv6, sorry. IPv6 route, since all the details are on the diagram there, and you say 2001 colon DB8 colon ACAD colon 1 double colon /64, okay, and you put S0/1/1 as the next hop. configure directly connected IPv6 static route on R3 to that network. The same thing, IPv6 route 2001 colon a card colon 3 double colon /64, and the exit interface is S0/1/1, right? Then another directly connected IPv6 route, static route on R3 to reach this network 2.0 network. So IPv6 route 2001 colon DB8 colon a card colon 2. Want us to exit this configuration
Excuse
mode?
me.
Yes.
I don't know if it's only from my side because we can't see
I'm wondering the same
the
thing.
demonstration. Yeah, it's
I can't see
delaying.
also. I've even
Yeah.
restarted.
Oh, you can. Oh, it's delaying.
I
Yeah,
think
it's
so.
delaying.
Oh, so okay. So you're not able to see it. Let me just share that again. So it's you guys are telling me it's delaying.
Yeah, it's delaying.
Maybe it's your network. It's delaying the packet.
I have totally lost power here, and I'm now using my phone as a hotspot, but it's causing chaos. I think it's also going off. I don't know. Can I say this? Can we have this class probably redone tomorrow for this part here?
Yeah, sure.
Yeah, sure.
Let's do this because because my phone is failing. So let's stop it at here, and we're gonna continue from here tomorrow in configuring this part. So this was part 1 of this. We'll do part 2 tomorrow, and there's a very small part on troubleshooting on chapter 16, and that will be it. So guys, sorry for that. Let's meet tomorrow to just finish up the remaining part. We still have a significant part here. We've not configured floating static routes. We have not configured host routes. We have not configured default static routes. We have not configured the, of course, the backup route. So let's end this for now. Let's meet tomorrow to be able to finalize this. I highly apologize for that particular hiccup. It's power has just gone, and I'm not on my Wi-Fi now. So sorry for that again, and I see you tomorrow, guys, to finish up on static routing. Otherwise, I think you guys have a wonderful evening. All right.